Our last question in our graphs in calculus is to graph the first differentiate of g of x and the first differentiate of h of x. Now remember, we're talking now, this is the slope of g of x and the slope of h of x. So when we say g of x, that is a function of y in terms of x, or g in terms of x. So we have an x and a y function, whereas here we're going to have slope and x. That's what our function is going to be instead. So instead of y, we're going to have slope as our y-axis, and then instead, as x, we keep it as x because it's in terms of x. So I'm going to just copy basically the same numbers that we have above. As you can see, there's no numbers on the y-axis, so we'll keep that the same. We won't put any numbers on the y-axis. We'll keep the same numbers on the x-axis. Now, the first job when we're doing this is we label this the first differentiate and we find our turning points, because our turning points, we know the slope is 0. So if I know my slope is 0, I can straight away put onto this, because this represents slope. Slope is 0 at -1 and slope is 0 at 2. And that's because if I go up here on the graph above, I can see my turning points are when x is 1 and x is 2. The next thing then is I look at the fact that for all of this section here, the slope is positive. Now, if the slope is positive, it means I have a plus number. And if I have a plus number, I need to be using this section of the y-axis, because remember, this is representing the slope number. So my slope number will be like this, okay? And as we said before, this slope decreases because it needs to get back to 0. So we might have a slope of 3, 2, 1, and 0 at the top. So that's why the numbers are decreasing. That's why that line is going down. In between the two turning points, I can see my slope is negative. And what we have is one point of inflection, and that is where the second differentiate equals 0. That is the lowest or the steepest part of that. That's the lowest slope that we have. The lowest slope here happens around 0.5. So around 0.5, I know I'm going to be at my lowest point, my lowest slope. And I go back up to 0 then, and I can see here then for the next part of the graph, my slope needs to be above 0. Why? Because it's a positive slope. Now, when we're doing these, what happens is, if I had what g of x actually is a function, it's a cubic function, so it might be something along the lines of this here. When I get the first differentiate of that, I'll end up with 3x squared minus 4x plus 3. So as we can see, our power decreases by 1. And if our power decreases by 1, we lose a turn. So here we had 2 turns because it's x cubed. Because now this function, once I differentiate it, will be x squared. An x squared function will have 1 turn. So anytime you're asked to identify which slope is which graph, we're talking about losing a turn with it. So there's our first one. Our second graph then, again, we stick with the same values. And I have 1 point there as a -1, -2, -3, -4. And they do have the y-axis labelled in here, but for us, we have x, we have the first differentiate of h of x, the slope. We won't know the slope numbers, so we'll just keep it as just an unknown value on the y. So first job is always find your turning point. There's my turning point there. So my turning point is where my slope is 0, because this represents slope. My slope is 0 there at the number -2. Now with something like this, because it's only got 1 turn, what I'm going to find here is that I'm going to lose a turn and we'll end up with a straight line. Because if this happened to be 2x squared plus 3x plus 4, if I differentiate that, I get 4x plus 3. That's the equation of a line. So you'll find that you'll always lose a turn. Here I can see my slope is increasing, so that's a positive slope, which means that I need to be above the line, above the x-axis for that. At the turning point then, my slope turns negative, so my line will go below the x-axis. And there is my graph for my first differentiate.